Imagine a force so powerful it can reshape weather across the entire planet. One that floods continents, dries out rainforests, and can even impact whole civilizations. Earth's climate is a delicate balance of orbital mechanics, atmospheric circulation, and seasonal cycles. But every few years, that balance snaps. The planet lurches into one of two extremes: El Niño or La Niña. The opposing phases of a climate engine called the Niño-Southern Oscillation. This cycle has been influencing Earth for tens of thousands of years, but this time, something has changed. The La Niña we're currently experiencing isn't playing by the old rules, and Earth's natural air conditioning unit has a problem. I'm Zinnia, and you're watching The Explorer Now. This is the science behind one of Earth's most powerful climate mechanisms. Join me as we unravel the mystery of La Niña's latest twist. We'll explain what La Niña is supposed to do and look at why this time is different and what it means for us. Is this a case of La Niña changing its playbook, or have we changed the playing field? To know why something isn't behaving as we expect, we need to know what it is in the first place. So let's start there. La Niña, which is Spanish for the little girl, and El Niño, Spanish for the boy, are opposite phases of the El Niño-Southern Oscillation cycle, or ENSO for short. Think of the Pacific Ocean like a massive seesaw for climate. This to and from cycle happens every 2 to 7 years, with El Niño or La Niña beginning in June, peaking in December, and usually dissipating by April. This isn't a new thing either. Planet Earth is incredibly resilient, enduring any number of climates in its history, including ENSO. Evidence of its influence reaches deep into the past. Its chemical fingerprints are preserved in ancient coral fossils and sediment cores stretching back tens of thousands of years. Written accounts of ENSO-related weather patterns date as far back as the 16th century. The in-between, where there is neither an El Niño nor a La Niña, is known as ENSO neutral, a balance between the two where conditions and temperatures hover around average, preventing the formation of either phenomenon. But that stability doesn't last. Small shifts in trade winds or ocean surface temperatures can act like a trigger, pushing the planet out of balance. And it doesn't take much. Just a 0.5 degrees C surface rise can trigger El Niño. And conversely, when temperatures dip below average, La Niña may develop. In the case of La Niña, unusually strong easterly trade winds push warm surface water westward toward Asia and Australia, allowing much cooler water to upwell along the coast of South America. The net effect is a large region of cooler than normal sea surface temperatures in the central and eastern tropical Pacific. These ocean changes alter atmospheric circulation, and La Niña strengthens the Pacific Walker circulation, a large atmospheric loop usually shifting jet streams northward. El Niño and La Niña are in a sort of climate tug-of-war. When one gains the upper hand, different regions around the world feel the pull in opposite ways. Or at least they should. You see, La Niña exposes a larger area of cool ocean water, and it acts almost like a temporary air conditioner for the planet. As a general rule of thumb, therefore, global average temperature often dips slightly during La Niña years compared to El Niño years. For example, if you look at the historical global temperature graph, strong La Niñas, like from 1999 to 2000 or even 2011, usually interrupt the warming trend a bit. In contrast, a big El Niño like the one we had in 1998 or even 2016 tends to spike global temperatures to new heights due to all that extra heat being released from the ocean. It's no surprise, therefore, that La Niña tends to deliver monsoon and tropical rainfall over Indonesia, the Philippines, and parts of India, and Australia often sees above-average rain and cooler temperatures, especially in eastern and northern regions. For the Americas, as the jet stream shifts northward, typically winter storms are pushed toward the Pacific Northwest and Canada, leaving swathes of California drier than average, especially in the south. It's a similar story in South America, too, where the northern parts, Colombia, Venezuela, and northern Brazil, are usually wetter, while some central and southern regions experience drier than normal conditions. ENSO's reach is truly global, and its effects are felt everywhere. A key insight from recent research in 2025 using NASA's GRACE satellite data found that La Niña and El Nino act like a global amplifier, shifting water distribution on a planetary scale. Nowhere is safe from its impact. They also found that ENSO has a synchronizing effect on water storage extremes across continents. What this means, essentially, is that when the Pacific flips, it can simultaneously tip some places into drought and others into floods. That's that seesaw effect we talked about earlier. During the strong 2010-2011 La Niña, Australia, southeast Brazil, and parts of Africa all experienced extreme precipitation at the same time. Conversely, large El Nino have caused droughts in disparate regions like South Africa and Amazonia. The study also found a shift over the past decade. Before 2011, wet extremes were more common, but since then, dry extremes have dominated, a sign that ENSO-driven water extremes are already changing. And that's our first clue. Traditionally, La Niña is nature's brake pedal on global warming. It's a bit of a cool down, but during the most recent cycle from late 2025 and into 2026, where I'm recording this now, something has changed. Not all La Niña are created equal. Some are roaring strong, others are barely there. The current La Niña, the one we're experiencing as I write this in January 2026, falls into the latter category. It's relatively weak and expected to be short-lived, like a La Niña light, if you will. Ocean measurements in November 2025 showed only borderline La Niña conditions with just enough cool water to even meet the threshold. And by early 2026, those cool anomalies have already started to fade. The World Meteorological Organization pegged the odds of this La Niña sticking around through February 2026 at only 55%, with nearly as high a chance it would fade back to neutral in the same time frame. In fact, by spring 2026, models show a rapid warming below the surface, signaling the collapse of La Niña might already be underway. A burst of westerly winds in the Pacific in January 2026 is actively tearing down the La Niña pattern, a sign that the Pacific is gearing up for a major flip toward El Nino later this year. Why does this matter? Well, a weak La Niña has a weaker pull on the climate. It's like the difference between a light tap and a hard yank on that climate tug of warp. When the La Niña signal is weak, other influences can overwhelm or muddy the pattern. As NASA oceanographer Josh Willis explains, when ENSO events are mild, whether La Niña or El Nino, the usual weather outcomes become notoriously difficult to predict. Not only is it weak, it's also short, and that's a problem. Take Australia, for example. According to their Bureau of Meteorology, this 2025 La Niña also formed relatively late in the year around October time, missing the prime season in the spring, which is when La Niña usually has its biggest effect on Australian rainfall. And then by the Australian summer, its influence was already waning. In its place, Australia is seeing more of its other climate drivers like warm Indian Ocean waters and southern hemisphere wind patterns dominating the weather, squashing this weak La Niña like a bug under its shoe. Conversely, in North America, the signature Southern California drought has so far been defied. Here, La Niña tends to correlate with dry water years, which the National Weather Service defines as from October the 1st to September the 30th. In fact, out of 25 La Niñas since 1954, 15 have brought drier than normal conditions to California. However, by December 2025, California experienced some record-breaking rain. In fact, there was so much of the wet stuff that it helped to put out some of the remnants of the autumn fire season and even started to refill reservoirs previously left dry. It was so unexpected it prompted the Los Angeles Times to ask, "What La Niña?" In summary, the goalposts have shifted. Something has changed. This La Niña came late. It isn't very strong and it won't stick around for very long. And whilst that might sound quite positive and bring short-term gains in California at least, the longer-term implications around the world are far more concerning. So why is this change happening? Well, there are several factors that are rewriting the ENSO script, with the most prominent being, you guessed it, global warming. Perhaps the biggest difference this time in the case of the 2025 La Niña is that the baseline climate is warmer. I made an entire video on exactly how much warmer if you want to check that out, and that changes the game for La Niña. Typically, La Niña should bring those cooler days and widespread rains down under. But Australia just saw one of its warmest October on record for ocean temperatures. Even with La Niña brewing, the surrounding seas were so warm that the extra heat counteracted La Niña's cooling tilt. The long-range outlook suggested many parts of Australia might get average to below average rainfall and hotter than normal weather, even while La Niña conditions persist. In other words, the planet's background warming is overwhelming La Niña. And it's not just Australia feeling this change. The United Nations WMO warned in late 2025 that even if La Niña returned, global temperatures are expected to be above average in the coming months. Why? Because the relentless climb of greenhouse gas-driven warming simply outguns the small cooling La Niña provides. Remember, La Niña is a temporary natural cool phase, but climate change is a long-term pervasive warming trend, and it doesn't take vacations. The recent triple-dip La Niña from 2020 to 2023 was a case in point. It was the first triple La Niña of the 21st century, and it's only occurred 3 times since reliable records began in the 1950s. Yes, it did intensify droughts and floods in various places, but it did nothing to break the run of exceptionally hot years. The bottom line is the past 10 years were still the hottest on record. La Niña or not, it's like me having my air conditioning on in my office. That's La Niña. But my room keeps getting hotter because in the corner I've got a furnace on. That's climate change. And there's more too. Crucially, a warmer atmosphere also holds more moisture. Now, this can mean 2 conflicting things. On one hand, drier regions might get even hotter and drier because there's more evaporation. But on the other hand, wind conditions do allow rain. There's more water vapor available to dump. So, rainfall extremes can be fiercer. And we don't necessarily know which way around this might happen. Climate change is essentially loading the dice for extremes, and the old patterns might not manifest the same way. The dice are weighted differently now. For instance, one paradoxical outcome that's currently being discussed in the scientific community is that, historically La Niña has the ability to curb global temperature rise, but in recent years we still keep breaking heat records during those years. But here's where it gets messed up, because when the next El Nino arrives on top of all this extra heat, it could do the opposite and propel global temperatures to new heights. Many experts are looking wearily at 2026 and 2027 already, when a forecasted El Nino could spike temperatures further. In fact, literally as I was recording this today on the 9th of February 2026, new data from the U.S. government's NOAA and Australia's Bureau of Meteorology said that if El Nino arrives in late 2026, then the knock-on effects would likely be record high temperatures in 2027. So, yes, something changed. This isn't a hunch of mine or a clickbaity title that this is measurable. Climate data confirms that the baseline has shifted. Our atmosphere is hotter than pre-industrial times, more energetic, and that change permeates every weather pattern. But it's not just global warming causing these changes. Another reason this La Niña isn't behaving by the book is that ENSO is not the only game in town. There are other climate drivers and a healthy dose of chaos in the atmosphere that can override or modulate ENSO's influence. And this year, some of those wild cards turned up. A prime example is the influence of atmospheric rivers, or ARs. These are long plumes of water vapor from the tropics and jet stream quirks on the U.S. West Coast. Normally, La Niña's north-shifted jet stream keeps Southern California dry. But late 2025 saw an unusual pattern. A persistent low-pressure system camped off the west coast, stretching farther south than usual for autumn. This low tapped directly into deep tropical moisture. Think warm, wet air from around Hawaii, the so-called Pineapple Express, and funneled a series of atmospheric river storms into California. And we've already talked about what happened here. 10 inches of rain already logged by early December in some areas. That's half a year's worth of rain in just 2 months. It turns out the type of storm responsible for this soaking in California is kryptonite to La Niña too, compounding matters even further. Atmospheric rivers are fueling these fires, or lack thereof. And it turns out La Niña and El Nino don't really control atmospheric rivers. A recent study published in Climate Dynamics found that ENSO mostly affects the typical winter storms that come from the North Pacific or Alaska, but not the big AR-driven storms from the subtropics. Those ARs are steered by more complex and often more random factors. So, California basically got hit by an AR lottery win or loss depending on how you view flooding, and it might well mean that all bets are off, not just here, but around the world. So, what comes next? I wish I could give you a nice, neat answer to take away and enjoy the rest of your day with, but based on all we've talked about, and I'm sure you've summed by now anyway, no one really knows. But we can have a pretty good guess because of how short this La Niña is, and in fact, by the time you watch this, it may already be on its way out. As we've alluded to in this video, what forecasters are looking at now is a potential major Pacific flip to El Nino by late 2026. In fact, the data suggests a kind of climate whiplash. After many months of La Niña's cold pattern, the Pacific is primed to swing hot. Now, if that happens, the winter of 2026-2027 could be completely different for America and even us over here in Europe. This shows how unusual this situation is. A short, weak La Niña that barely showed up and will be gone in the blink of an eye, flipping to what could become a strong El Nino. Historically, such quick turnarounds can be jolting. It means within a year or so, regions might go from one extreme to the other. For example, if California surprisingly got a wet La Niña winter this year, could it get hammered by an even wetter El Nino winter next year? Or in reverse, parts of Australia that didn't see expected La Niña rains might face severe drought and heat if El Nino arrives on schedule. The climate system gears are shifting fast. So what are the implications of this misbehaving La Niña and the changes surrounding it, especially for us? Well, firstly, all of this is a rather stark reminder of just how connected our world is through these climate patterns. When La Niña or El Nino acts up, it's not just one region dealing with a headache, it's often multiple regions simultaneously. As we touched on earlier, scientists using NASA's GRACE satellites, which measure Earth's water storage, found that ENSO is the primary driver of extreme water shortages and surpluses worldwide in the satellite record. In practical terms, this means a single La Niña event could cause agricultural crisis in Africa and flooding emergencies in Asia at the same time. For instance, while 2010 and 2011's La Niña was flooding Brisbane and Sao Paulo, it was also contributing to drought in the Horn of Africa. These synchronized extremes put a big strain on the global system. If multiple breadbasket regions get hit, one with a drought, one with a flood, concurrently, it can disrupt food supply and even trade. The catch is, if this La Niña is not doing what's expected, it throws off some of that planning. Regions that were gearing up for one scenario, say drought relief that never came or mild climate conditions that turned extreme, well, they can be caught wrong-footed. It's a reminder that climate preparedness needs to be flexible and account for a range of outcomes, not just the most likely forecast. We're also likely staring down more volatile swings in our climate. Climate change isn't making ENSO go away. If anything, it might amp up the extremes of it. We saw a preview of this in California in recent years. Horrific wildfires and empty reservoirs between the 2020, 2012, and 2016 drought, which have both La Niña and El Nino influences. Then a flood barrage in 2017 where La Niña brought big storms, then another drought by 2020, and then 31 atmospheric river storms in the winter of 2022-2023, which broke all rainfall records. To me, La Niña and El Nino are like the hands on the steering wheel. But climate change has its foot on the gas pedal, making the swerves even more violent. If that all sounds a bit doom and gloom to you, which it does to me, and you're looking for some positivity, and amongst all of this, on the bright side, our understanding of these patterns has grown immensely. Agencies like NOAA, the WMO, and various research institutes are monitoring the Pacific with cutting-edge satellites. There's things like the new Sentinel-6 series that observes ocean conditions in detail and various computer models. We often get a heads-up months in advance if La Niña or El Nino is forming, and that lead time is crucial. The key is using that information wisely, but also not being overconfident in the historical rules of ENSO. Basically, prepare for La Niña, but brace for anything should be on the fronts of any t-shirt these scientists are wearing. In the end, the tale of this La Niña is a microcosm of our changing climate reality. A normally familiar pattern decided to not behave in a familiar way. It reminds us that we're living through an era where old assumptions may not hold, and we're entering the unknown, a new normal, and things are changing. Yes, La Niña is still La Niña, and the Pacific Ocean is still doing what it does, but the context around it is different. What keeps me positive is the hope that we will watch and learn. So often, it's the systems we can't see that have the most impact and are often the things we think about last. Each surprise is a lesson that can improve forecasts and preparedness. The fact that researchers quickly identified why California got soaked from those atmospheric rivers, or why Australia might stay hot due to the global warming influence, means our scientific toolkit is getting sharper. And knowledge, my friends, is power. The more we understand these evolving patterns, the better we can anticipate and adapt to whatever climate curveballs come our way.